Hello everyone. I am Mrs. D. Shanti Challaya, working as Assistant Professor in EC Department at Sri Muthukumaran Institute of Technology. I am going to handle one topic, simplification of Boolean expression using K-map under the subject Digital System Design for 3rd semester ECE in Regulation 2021. Now we will discuss the method of Karnaugh map. Karnaugh map is nothing but it is a method used to reduce the Boolean expression to a minimum number of literals. It is devised after the name Karnaugh, who has devised this method. It is actually a truth table in another form. It offers a graph of reducing a digital circuit to its minimum number of gates. Now we will discuss the features of K-map. Karnaugh maps can be used on small circuits having 2 to 3 inputs as an alternative to Boolean algebra. And on more complex circuits having up to 6 inputs, it can provide quicker and simpler minimization than Boolean algebra. What is Boolean algebra? Boolean algebra is formed by Boolean laws and postulates, which is used method to simplify the Boolean expressions to the minimum literals. Boolean algebra has certain disadvantages, that is, it could not minimize the function to the minimum variables as compared to K-map. K-map obtains result variables and less time consuming as compared to Boolean algebra. Now we will discuss the K-map representation. Here it shows the K-map with 2 variables, the next figure is with 3 variables, and the next table is 4 variables. 2 variables with A and B, which has 4 squares, and in figure B it is represented variable map, which is nothing but 8 squares, and the figure C is represented with a function with 4 variables in which we have totally 16 squares. So the representation of K-map for 2, 3 and 4 variables respectively, it is shown in the figure. How to construct the K-map? Shape and size of the map is dependent on the number of binary inputs in the circuit to be analyzed. The 2 input circuits, for example, with the variables A and B, which is shown in figure A, it is provided with 2 power 2, which is equal to 4 cells. Next you see the figure B, which is with 3 variables, which indicates that a circuit has 3 inputs with the variables A, B and C. It has totally 8 cells, which is nothing but 2 power 3 is equal to 8 cells. Similarly, in figure C, if you see, you have 4 variables in which we have 16 squares or 16 cells, which is 2 power 4 is equal to 16 cells. At the outset, an n input circuit will require a map with 2 power n cells. In K-maps, the cells are ordered in gray code and each cell position represents one combination of input conditions, while each cell value represents the corresponding output value. What do you mean by gray code? Gray code is nothing but it is another form of binary system. So for example, in binary representation, 1 is given as 0, 1 and 2 is represented as 1, 0. Whereas in gray code, these values are represented as 0, 1 and 1, 1. What is the difference between these two? When you see in binary 0, 1 and 1, 0, both the position changed. 1 is changed to 0 and 0 is changed to 1. Whereas in gray code, 0, 1 represents 1 and 1, 1 represents 2, in which only one position is changed and another position remains the same as 1. Similarly, if you see the gray code, here in the column given as 0, 0, 0, 1, 1, 1, 0. So in the successive codes, if you see, only one position will change, other position bit will remains the same. In all 3-bit binary and 3-bit gray code also is the same thing. So in K-map, the cells are ordered in gray code in such a way, in the successive only one bit is changed and the other bit remains the same. We will discuss the K-map with an example. So in the problem given here, simplify a plus a bar by use of K-map. The function is given as a plus a bar. So the minterm expression is nothing but a and another one is a bar b. So here function has 2 variables a and b. So we have to draw the K-map with 2 variables a and b, which is nothing but a 2 by 2 matrix form which consists of 4 cells here. So if you see the diagram on the right hand side, I have represented a K-map with all A and B. A on columns, it will represent 0 and 1, and in rows it represents 0 and 1 for B. So inside the cell it is represented as A bar B bar, A bar B, A B bar and A B successively. So for A bar B, mark the 1 on one side, and for A, the term you have to take for both B as 0 and B as 1, and hence AB bar and AB is marked as 1. So for the term A, mark 1 for both cells AB bar and AB. In K-map, we will put 1 in the cell wherein value of A and B are specified in the Boolean expression, that is F is equal to A plus A bar, in which the minterm expression you take A as 1 and A bar as 0, and similarly B as 1 and B bar as 0 is there. Now in the expression, first see the first term is A. Here we are going to take both the values of B as B and B bar, which is B as 1 and B bar as 0. So far the given Boolean expression, we will take the first term as 1 0 and 1 1. As value is not given, we are considering it as both 0 and 1. Now if we have put 1 in the cell where cell positions are 1 0, 1 1 and 0 1. So now the next step, we have to group the adjacent one and find the minimum. So here I have grouped the adjacent one. So you have vertical column as well as horizontal column. So for the first group, you see the vertical oval, so which is given as 0 1 and 1 1. So in both 0 1 and 1 1, the common bit is 1, which comes to B. Hence the minimum literal is B. In the second group, you consider the horizontal oval shape, which corresponds to 1 0 and 1 1, in which the first bit 1 is same, which corresponds to A. So it is A. So the resultant solution is A plus B. So now the representation of minterms in K-map can be discussed now. So first you see the two variable map, which is given as A and B. So A is on column side and B on horizontal side. So A will have values both 0 and 1. B will have both values 0 and 1. Inside the square, it is marked as 0 1, then 2 and 3, which corresponds to AB as 0 0, 0 1, 1 0 and 1 1. So thus it is a two variable K-map. And next is the representation of minterm in the three map. Three variable map, A we have on rows, and in column we have BC, B and C, two variable. So for one variable A, we will have either value 0 or 1. For two variables, you will have 4 values approximately. So BC can be 0 0, 0 1, 1 1 or 1 0. As we have discussed earlier, it is arranged in gray code format, 0 0, 0 1, and next if you keep 1 0, both the bits will change. So you cannot keep adjacent to 0 1, 1 0, and you can have 1 1 and add 1 0. So if you see the successive combinations, only one bit will change and the other bit remains the same. Now inside the square, you have 0, 1, 2 and 3 will be the third square, and 4, 5, 6, 7 will be in between middle square, very continuous. So that we have to keep it in mind and mark the minterms accordingly. So next variable, 4 variable K-map. So in this you have A, B, C, D. AB on rows and CD on column. So AB also have two variables. So you have 0, 0, 0, 1, 1, 0 on rows. Similarly, CD is two variable. So you have 0, 0, 0, 1, 1, 1 and 1, 0. Totally you have 16 squares, which corresponds to 16 minterms ranging from 0, 1, 2, 3 and so on up to 15. So successively you have 1, 2 on corner position and 3 in the middle. Then the second row 4, 5 and corner is 6 and the middle one is 7. And come to the last row 8, 9 and then corner is 10 next is 11. And then the third row will correspond to 12, 13, corner 1 is 14 and 15. This corresponds to the min term of your 4 variable K map. Now we will discuss the min terms and max terms for 3 variables. So before going to the terms inside the table, we should know what is min term, what is max term. Min term is nothing but product terms and max term is nothing but sum terms. So min terms, sum of products, which is otherwise SOP, and max terms, which is called sum terms, which is otherwise called as product of sums, POS. So now coming to the variables, input variables, if it is A, B and C, 3 variables, you have totally 8 combinations from 0, 0, 0, 0, 0, 1 and so on up to all ones 1, 1, 1. So that means you have 8 min terms ranging from M0 to M7, which corresponds to the product terms of 3 variables A, B and C. If it is 0, it is represented as complement, and if it is 1, it is represents the same variable. And for example, if it is 0, 0, 1, 0, 0 is A bar, B bar and 1 which is nothing but M1. And similarly max terms A plus B plus C. So here 0 is taken as it is and 1 means it will given the complement. For example, if it is 1, 0, 0, C, M4, 1 is A bar and 0, 0 will be B and C with a plus. So this refers to variables with min terms and max term. Similarly, if it is a 4 variable, you have 16 terms ranging from M0 to M15 in both min terms and max term. Min terms is represented as small m and max terms is represented as m. And product terms always refer as sigma, whereas sum terms represent always as pi model. Now we will discuss the representation of min terms inside the 4 variable map. See the first one, SOP, which is otherwise called min terms. Here the 4 variables are represented as A, B and C, D. So as we have discussed earlier, AB means 0, 0, 0, 1, 1, 1, 1. So if it is 0, you represent the variable with bar. If it is 1, you represent the variable as it is. For example, if it is 0, 0, it is A bar, B bar. If it is 1, 1, it is AB. Similarly, CD corresponds to 0, 0, 0, 1, 1, 1, 1, 0. So it is C bar, D bar, C bar, D, CD, CD bar. So them are ranging from M0, M1, M2, M3. So for example, if it is M4, it is A bar B, C, D bar. Similarly, for example, if you take 15, M15, it corresponds to A, B, C, D. Similarly, POS, product of sums, otherwise called as max term. So 0, 0, here the product term is represented as A bar, B bar. Same way, vice versa, for max term, 0, 0 is represented as A plus B. Okay, so 0, 1 will be A plus B bar. 1, 1, A bar plus B bar. Same rule applies to CD variable. So sum of products means min terms and product of sum is max terms. Rules for simplifying the Boolean expressions using K-map is discussed now. The groups may include all ones. If have 0 in any squares, 0 cannot be included along with 1 and it cannot be grouped. That is not correct. Only adjacent ones can be grouped as shown in the first table with the 2 variable map. Similarly, you cannot group in diagonal. You can group only either horizontal or vertical in a straight line. Next is in a 3 variable map. For example, 4 ones in one row, you have to club all 4 ones. You cannot group individually as 2 ones as shown in the figure. It is not correct. So you have to follow the rules for grouping the ones to the maximum. So for example, in a variable map, if all 8 squares are 1, the result is 1. If adjacent 4 squares are grouped, then the result will be a 1 variable. If 2 squares are grouped, it is 2 variable, and if a 1 remains separately, it is resulted to 3 variables. So you can group either 1, 2 and 4 and 8 in a double form. In the you cannot group in the odd numbers 3, 5 likewise. So it is applicable to all variable maps, 3 variable, 4 variable, 5 variable. We will solve one problem for a 3 variable expression. The expression is given as a bar b bar c plus a bar b c plus a b bar c plus a b c. So you draw a 3 variable map which consists of a on one side and b c on other side. A corresponds to 0 and BC corresponds to 0, 0, 0, 1, 1, 1, 1, 0. As we have represented earlier, A bar B bar C is nothing but the second square. A bar means it corresponds to 0. B bar C means it is 0, 1. So 0, 0, 1, you can mark the 1. Similarly, A bar BC is 0, 1, 1. So it is the third square in the first row. Next is A B bar C. It is in the second row. A1, 0, 1. Next is ABC, all ones, 1. So you have 4 ones inside the square. So in the function given, you have 4 in the problem given. So you cross verify whether all 4 terms has been marked inside the map. So now it has all the 4 terms are marked inside the map, and now you group the adjacent one. So all 4 ones are adjacent to each other. So you can group accordingly. Now we have to write the result, which is result single variable. So row wise you cannot take because both it is changed 0 and 1. Column wise if you take 0, 1 and 1, 1, 1 is common which corresponds to C. Hence the output is C. So the given function consists of 3 variables, but after simplification the result is variable. Thus it is simplified to 1 variable using K-map. Now we will see another example which is given as f of ABC is equal to a bar c plus a b bar c plus b bar c bar. In this term, in this function, here we have 3 terms and it is a function of 3 variables. So first you have to convert the standard SOP to canonical SOP. So what do you mean by canonical SOP? It should, all the terms should contain all the variables. So you first consider the first term a bar c. In this term the variable b is missing. So you include b bar in the term. So a bar into b plus b bar into c. And next term, second term is b bar c. You have all 3 variables. You leave it. Then next is b bar c bar. In this variable a is missing. So you have to include in that. So plus a bar into b bar c bar. So the function is actually a bar b c, a bar b bar c plus a b bar c bar plus a bar b bar c bar. And this a b bar c actually you have, it is repeated. So you have considered as one term and the result is actually 4 terms in the function. So you mark a bar bc. A bar bc is marked as represented in the variable map. Similarly, next is a bar b bar c. That is also marked as given in the other 2 term. So now first you see whether all 8 ones can be grouped. It cannot be grouped. And next you see for 4 ones. 4 ones are also not adjacent. So 2 ones if you see, you have either horizontal and vertical. You might think the first 2 squares whether it can be, already it has been covered by another group. So additional term is not required in this. It is not essential. So each implicant we call it as, each term which has to be grouped is called as prime implicant. In that essential prime implicants can alone taken for simplification. So now the vertical group. Vertical group it corresponds to b bar c bar. Horizontal group, horizontal row a bar has to be taken, and in the vertical b bar c and bc, c is common. So it is a bar c. So the resultant expression is b bar c bar plus a bar c. Next is example for 4 variable map. The function given is consists of 4 variables in all the terms. So otherwise it is also represented in min terms, sigma m of 0, 1, 3, 4, 5, 7, 12, 13 and 15. So it is a 4 variable map. So first represents the 4 variable map with min term 0, 1, 2, 3. So totally you have 4 plus 4, 8 terms in the problem. 8 plus 1, 9 terms in the problem. So you have to mark 9 squares inside the map. So we have marked all the 9 ones inside the marble, and whichever is not given can be marked as 0. Now we have to see the grouping. So adjacent 8 ones, if you see, it is not there. So you can consider next 4 ones. So 4 ones are grouped as given in the third table. So 4 terms. First you see the blue color one, which is corresponds to, in row 0001, 0 is common, which corresponds to A bar. In column 0001, 0 is common, which corresponds to C bar. So the first term, if you see in the function f of a, b, c, d, A bar, C. The next square 0001, 0 is common, A bar. Then 0111, 1 is common, which corresponds to D. Hence it is A bar, D. Similarly, other 2 squares have been taken, B, C bar and B, D. The result is A bar C, A bar D plus B, C bar plus B, D, which is the simplification of the expression which is given in 4 variables. Thus, the circuit obtained will be simpler than the function given, and accordingly the complexity is reduced. Next problem, it is given as minterms m1 plus m2 plus m3. This is another representation of giving a problem. So here again it is a 4 variable map. You draw the 4 variable map, mark the minterm. So m1 corresponds to 1, m2 corresponds to 2, m3 to clearly other term. So totally you have 7 terms, 7 ones are marked here, and it is grouped accordingly. Now you can see a difference between the previous problem and this problem. Here 2 ones have been clubbed as F1, and F2, if you see, 2 ones has been. Now F3 is nothing but 4 ones, but it is not, actually it is not seen adjacent, but virtually they are adjacent to each other. You can take corner ones, all corner ones can be considered as adjacent, and all corner rows and columns can be taken as adjacent each other. So this 2, 3 and 10, 11 are considered to be adjacent to each other. So how you have to write the term for this F3? Here you see the row, first row and last row. A bar, B bar is common. So it is B bar. And the if you take, it is CD and CD bar, C is common. So it is B bar, C. Thus the function is obtained with 3 terms, A bar, B bar, D plus A, C bar, D bar plus B bar, C. This is another way of grouping the adjacent ones. Now we will discuss a problem with including don't care conditions. The problem given is f of a, b, c, d with sigma m of 2, 3, 4, 6, 11, 12 plus d of 10, 13, 14. D is nothing but don't care condition. Don't care means it can take the value either 0 or 1. So you draw a 4 variable map, mark the minterms which is given as 2, 3, 4, 6, 11, 12 as 1, and don't care condition as x. Here it is 3 don't care is given, x. 3 don't care, x has been marked here. Here how to group? 1 can be grouped along with x. X alone cannot be grouped. So that's what here it is considered, and here you have 2 groups. One is the first column and the last column, one has been grouped, and first row and last row has been grouped with 4 squares. So when you take the column 0001 corresponds to D bar, and 0111 corresponds to B. So it is B, D bar. And now if you take the row 1110, 1 corresponds to C, and 0010 corresponds to B bar, it is B bar C. Hence group 1 is B bar C and group 2 B D bar. Thus it is reduced along considering the don't care conditions. Now we will discuss a problem to represent in product of sum. The sum given is sigma of 0, 2, 3, 6, 7 plus don't care of 8, 10, 11, 15, and has been asked to represent as product of sum. So we have to write the product of sum terms in the map, and we have to obtain the expression. Product of sum term is nothing but the remaining terms which is given other than sigma of 0, 2, 3, 6, 7, which is nothing but 1, 4, 5, 9, 12, 13, 14, and don't care is 8, 10, 11, 15. So the terms given with pi is marked inside the map as shown in the table, and the grouping is done as the same rule as we have followed for sum of product. So second column all zeros is grouped and it corresponds to C plus D bar, and the next group corresponds to B bar plus C, and third row and fourth row squares are grouped along with X and it corresponds to A bar. Hence you have C plus D bar into B bar plus C into A bar, which is represented as product of sums. Now we have discussed the sample problems how to reduce the Boolean expression using K-map. Even then it is simplified. You have some limitations of K-map. It is inconvenient to handle large number of variables. You cannot draw more squares for 6 variables and 7 variables accordingly. And it also depends on the human ability for recognizing the essential prime implicants, and it may not ensure minimized expression, and it is not suitable for accurate computer solution. Hence, the alternative solution to minimize the Boolean expression is Quine-McCluskey or tabulation method. Quine-McCluskey has been devised by two scientists, Quine and Kluskey, and it is named after that. Thank you.